Okay, good morning. As Lauren said, I'm John Calkins. I'm with Esri, been around for 22 years. Always been based in Colorado, which has been nice. And what I do at Esri is basically educate people about the possibilities of what you can do with GIS. How do geographic information systems, how does digital mapping, how does intelligent mapping, and the analysis behind it help you solve the problems that you're faced with in the world. So I was asked today to talk about sort of the future. What's spatial analytics? What's GIS going to look like 10, 20 years, 5 years from now? That's a very hard question to answer. Things are changing so fast that I almost wanted to say I didn't want to come up here today to talk about that because, to be honest, in some ways we don't know. Things are evolving so fast, and it's really hard to look into that crystal ball. But I'm going to give you some hints, and I think more importantly, I want to give you some challenges about where we need help. Because that's really the opportunity, or if I'm coming to a college campus, where can you guys sort of push the envelope and start to take things beyond what's happening today? So I sort of changed the title of the talk to go from sand and GIS to geo-collaboration. Where we're going to end up is a geo-collaboration, but I want to sort of give you some ideas about how things start and where some of these problems are that we're facing today. So we're going to go halfway around the world to some little sandy area in north-central China. And unlike, I hope, some of the talks that you've been going through today where it's all one-way preaching, we're going to turn this into a little more academic class, and you guys are going to have a chance to interact. Because what I want you to do is look at this high-resolution satellite image and tell me what you're looking at. That wasn't a rhetorical question. You raise your hand or you shout out the answer. I mean, this is a real geospatial problem. Nope.
Is this the one where they recreated a landscape from somewhere else here?
We'll give everybody else a chance to figure out. Can you figure out what you're looking at? And what's unique about this?
Are you talking about the left thing or the right thing?
I'm actually talking about what's outlined in the red box.
Okay, that helps. A river?
Water features.
Golf course? No?
Well, it's not contiguous with the surrounding area for one thing.
It's not contiguous. So the terrain changes radically along those red lines, those straight edges. Does that happen in nature?
No.
Not very often. Not ever, to be honest. So what you're looking at here is something that's man-made. So why would you create something that looks like a natural landscape that's man-made in the middle of the desert?
War games.
War games. Okay, so you were onto it, you're onto the right subject. So this is a Chinese military installation, and what they've created is a large sand table that they can actually walk out on to understand what's going on in this terrain. So it's the way that people have been planning battles and wars for generations, and that is to visualize the terrain, because the terrain is one of the most important aspects of warfare. But that block is a square kilometer in size. So then the next question is, what area does that represent? So how do you figure out if you've got that artificial sand table that's a square kilometer in size, what area does it represent? How do you answer that question? It's a very difficult problem. I mean, we know how to have systems that do facial recognition, but have you ever seen a system that does geographic recognition? You have.
It takes pictures of mountains and actually goes through and recognizes which mountain you take a picture.
Which mountain? But of a,
Like looking down
Looking
from
down?
a mountain and
Okay.
looking there.
where have you seen that?
One of my friends actually I think it was UNESCO.
Okay, well, you just ruined the whole presentation because nobody else has seen that before, so we'll have to talk later. Okay. Well, you just ruined my presentation. So you want to get up here and finish this now? Okay, so where this area actually represents, through a lot more challenging technologies, or lack thereof, to figure that out, is an area that's along the India-Pakistan-China border. It's an area that's 500 kilometers on a side. So it's one 500 scale model of this area. And if you want to see how that looks, so I'm going to go back and forth a couple times. In the upper right-hand corner is the sand table model, and you can see how it overlays almost perfectly. And the best way to look at it is look at the dark lakes and see how well those match. So through a lot of trial and error, people have figured out where this area represents. But there's something that's very unique about this area. This is a disputed territory between India and China. It's the area called Aksai Chin that for decades, China and India have been fighting over who owns that particular territory. So it's an area that's politically sensitive. You've got a sand table model that covers this area, but what is on that sand table model that's not in the natural world? There's something else unique that you didn't catch yet.
Fortification.
No? The pale blue areas. Who said that? Okay. So what are those pale blue areas? Or I'll make them yellow to make it a little easier to see. What do those represent?
Water.
Routes.
Drainages.
Those water, no. Roads, no.
Valleys.
Pardon me?
It's valleys.
Valleys, they are some of the valleys, but they're not just the valleys.
That's a really big one to
Keep going.
Gold.
They might consider it gold, but it's not. I don't
So there's
think
like
it's
big
gold.
access routes.
Access routes. Okay, that starts to be the clue. A sand table model is used to understand the lay of the land for your battle. What the Chinese have done, the hypothesis, is they've actually laid out those access routes. The courses of action is what the Army would call it, of how you move a battalion, how you move troops into that area across the terrain, across open terrain. Not just along the roads, but basically driving over anything and everything that you need to get there. So this area gets even more intriguing because in the early 1960s, there was a war fought over this territory. And there were some distinct battlefields that were set up along those borders. That's where those battles were planned. And you'll see that those yellow areas basically appear to be the routes into those historical battlefields. If that was the hypothesis, how do you prove that? You get into your geographic information modeling, your analysis, where you take the terrain and you figure out, well, how steep can you move your tanks over the terrain? How can you cross mountain passes? How do you not drive across water? How do you use the roads that exist, but not just limited to the roads? So that gets into all the modeling, and what the models tell you is those blue lines here are the shortest paths to move your troops in from the north across the roads in the open terrain. If those are the shortest paths, how can your enemy attack you would be the line of sight in many cases as you're moving through those valleys, which many of these were. And those pink areas represent now all the line of sight areas that you have to protect yourself from rocket-propelled grenades, from artillery, from other things that may intersect your plans. So this starts to be a very interesting problem. And it was a geographic problem that had to be solved by using some fairly sophisticated spatial analytics. But what I really wanted to focus in on is how did you actually solve that problem? How did we solve that problem and answer those questions? It started with a satellite image that was collected. So somebody had to know to task the satellite over that area. Satellite companies do not collect the whole world every day at high resolution. They're targeted collections for things of interest. So somebody had to point that satellite to the right area. The next person had to interpret that satellite image and say, what was that sand table looking thing that you were looking at? Before the red lines were drawn to focus your eye on that, you had to scan thousands and thousands of square kilometers of imagery trying to find those anomalies. From there, once you knew it was a sand table, then there was some effort to go through and validate that. Then there was that task of trying to match that. Back when this project was done a few years ago, there was nothing from your friend that could identify geographic patterns. So that was the luck of a draw that somebody was able to figure that out. And I'll give credit to my good colleague here from Google because that's where it happened. The image that was tasked by, I will speculate, a military organization showed up on Google, and then with billions and billions, or what do you say, millions, billions of eyes? How many eyes?
Lots.
Lots of eyes. Lots of eyes looking at that, they were able to go in and figure out what exactly that area represented. But the problem was that's where it stopped. Nobody else went in and figured out in the public world what those blue lines represented. It took another group of people to come in and figure out that those were the courses of actions and battle plans that the Chinese were training their troops on, either for offensive or defensive maneuvers. So this was a huge geo-collaboration problem that required many, many different people to work together to solve it. And that's really where I think the future of the technology is going to have to happen, because we don't have all the tools in place to do this level of geo-collaboration yet. So I want to talk about some things that are going to help to change that, sort of plant the seeds on how the platform, how the technologies are evolving, and what's going to give you sort of the basis to start and hopefully start to come up with the ideas to develop some of these new tools. The platform is changing. It's changing very radically. Years ago, you all thought, not you, generations before thought it was a geocentric world. The Earth was at the center of the universe. And we thought GIS, Geographic Information Systems, were the center of the universe as well. It was a bunch of geeks that were working on Unix workstations, locked in rooms that nobody ever saw, and that's where this spatial analysis happened. Locked away in the intel agencies doing this kind of analysis. Well, that's starting to change. That has changed quite a bit, because we're no longer geocentric. We've migrated past that into what you might call desktop-centric, where there's lots of people working on their workstations trying to figure these things out. There's lots of people that are using Google Earth, looking at those images and just picking out the anomaly, because that's way more eyes than the intelligence agencies have. But we're actually in the next huge phase of development, and that is we're switching to more of a user or person-centric world. This is being powered by the cloud, where it's not that the problems are going to be solved on the desktop, but the problems are going to be solved on the desktop or the laptop, the mobile devices, anywhere you are. It's the combination of all of these together that's going to start to solve the problems of the world. So it's really changing the platform of where all this information is coming to us from. So at Esri, one of the things we're doing is really trying to build out this cloud software as a service platform that enables all of these pieces to come together. And I don't want to go through all the details because this talk wasn't really about the architecture, but if you look around at the top row, the phones, the tablets, the browsers, things like Microsoft Office, where every Office user can plug in to a geographic information system, these are the things that are really starting to change the possibilities of collaboration. The first one, if I said, was platform. The second one I'll mention is content. Content is changing radically as well. We've seen more and more content over the last 20 years go from the back offices into the public domain, where more and more people can consume that. And that's really tied to what I called number 3 here, is the momentum. And that's, you can see the data availability has been growing exponentially. The number of participants has been growing exponentially. The spatial analytics hasn't been growing exponentially. It's more of a linear growth. The rules of space and time, the physics of space and time haven't changed that much over the last couple decades. So the tools are sort of slowly progressing. There are always new tools coming along, but they haven't seen a huge growth. This one up in the upper right is the one that I'm going to be a little bit of a heretic and say that our capabilities have actually faltered in the last 10 years. They've dropped off. And the reason why is because of the stupidity of the web and the internet. Now we probably can't use that videotape because I just insulted a whole bunch of people. But what happens is, as we've been shifting geographic information systems to work on the web, we've had to dumb everything down. And it's not just Esri, I would say it's sort of the symptom of the whole community. So the focus was, well, we've got to take all of this smart maps and intelligence and get it out to the public, get it out on the web. That's great, but it's almost like starting over. Well, you've got to figure out new ways to do that, and things get a lot more simplistic. So we've actually seen a drop, in my personal opinion, of the sophistication of how geographic information is used on the web. Yes, it is more pervasive, but is it really more sophisticated? And the other variable that gets in there, which I'm also a heretic for saying, is standards. Standards also dumb everything down, because they have to be the lowest common denominator that everybody can agree on and everybody can implement. So you combine those two things together, and we sort of have this lull in the history and the development of geographic technologies where we were sort of playing catch-up. I think we actually have just gotten to the point where it's almost back to where we were 10 years ago. So the spatial analysis tools are starting to come back into play, and now you're seeing those on the web and with some of the web technologies. So what that does is hopefully it's positioning us now for the beginning of true geo-collaboration. But we've got some challenges. This was the magic slide. This is my crystal ball for what the future looks like. And I don't know what these answers are, but I'll tell you right now, the hardest one is working together. I want to ask this question. How many of you have ever written a Word document together with somebody else? How many of you have done it linearly or all at the same time? All at the same time. You can collaborate. Both people open up the same document at the same time and you can write together. Is that what you're raising your hands? Sort of. Okay. Everybody can take the document, pass it to somebody else, pass it to somebody else, pass it to somebody else, and track those changes. But to truly collaborate at the same time starts to become a lot more complicated. The problem of the Chinese sand table was very much a linear collaboration. One person did something, went to the next, went to the next. It gets very, very difficult to say, how do you work together on a spatial map? In the old days, I could put a map on this table, spread it out, and we could all gather around, and we could point, we could draw on it, we could start to ask questions and hypothesize. Try doing that in a digital world, and the tools, in my opinion, don't exist yet. You watched the keynotes this morning, and how many of you noticed when the slides didn't keep up with the speaker? So the technology failed us. It was very hard to collaborate on those slides because we never saw some of those slides that he was advancing. We saw the other great demo from HP about drawing on the Word document, not a Word document, it looked more like it was a PDF markup. Yeah, it was great to circle and draw things, but nobody could type anything. Nobody could change some of that text with those interfaces we saw. So a lot of that doesn't truly exist yet. Yeah, we can share desktops, we can start to get there, but the systems are not nearly sophisticated enough to solve some of these complex problems. Did you have a question?
Well, Google Docs is getting fairly close, at least for altering text together. We were just using that in a project and you can simultaneously edit
Right.
documents.
How many people truly are using that? I don't want to ask that question. You'll say lots and lots. So now try to do that with a map, though. That's the point. For words, Word documents, it's much easier. Do we have the tools to do it for the map? I haven't seen them yet. Does your friend have those? Okay. I came up here to learn just as much as you guys came to learn. So this one's going to take some work. That's where the opportunity is going to lie in probably the next 10 years. Large databases, big databases, pick your favorite word. That starts to be very complex. We're all running around marketing and hyping the cloud. The cloud is going to solve all the world's problems. But when you're talking about terabytes of imagery and moving that around rapidly, it takes time and it's not quite as easy as the marketing speak likes to make it. The complexity, these are spatial problems are often very complicated, and hopefully I was using that Chinese sand table as an example of that. How do you answer all those questions? The metadata question, 10 years ago everybody said metadata was important. Now we've forgotten about metadata because it's boring and it's painful. But last time you guys looked at a map, did you check the metadata to figure out how authoritative was it? When was the last time it was updated? What are all the limitations on it? Or do we just assume that everything's correct? And people are going to start to get burned by that more and more as we keep adding more different types of data out there, different sources, some authoritative, some not. And then the biggest one, kind of the last sort of holy grail, is agility. When you look at commercial companies, governments, anybody that's out there, let's sort of say, how do I say this without offending anybody? Once you get outside of academic, did I offend anybody? You have to be very agile. The business community turns and tries to turn very quickly. Governments responding to problems like defense threats, like from that Chinese sand table, have to respond very quickly. So your ability to solve these problems, to bring all the information together, to bring the group of people together, to work together to solve that problem is incredibly valuable. And sort of the last proof point, that Chinese sand table, the analysis I showed you there, that resulted in a $50 million program change at one of our intel agencies. So that one simple project that I showed you there was worth $50 million to one of our intel agencies. So with that, I will tell you that the future is really about collaboration. and how we solve the problems together. Any questions?